The division algorithm and the remainder theorem can be very difficult to determine the zeros of some higher degree polynomial equations, as we have seen how, however, once a polynomial is in the factors form, it becomes much easier to recognize that zeros of that polynomial. In this section, we will investigate how using polynomial division can help us find factors of a given polynomial. Let's take a look at the division algorithm theorem. Move it a little bit up. Ahead. Let Px and dx be polynomials such that the dx is not zero, with the degree of the d is less than or equal to the degree of the p. Then there are unique polynomials qx and rx. I'm gonna use the qx here and the rx here, and we call the qx the quotient and rx the remainder. With this relationship, if we divide all by dx, since the dx is not zero, so we can divide every term without looking at the term that's undefined. So when you divide by dx, it transforms into another equation in this box, and the qx times dx divided by dx becomes the plain qx. The rx divided by dx becomes the last fraction here. We call the dx the divisor, the q quotient, r as a remainder. In this case, the degree of the remainder r is less than the degree of the divisor d, or the remainder is zero, in which case we say d divides evenly into polynomial p. If the remainder is zero, the two polynomials q and d are factors of the polynomial p. Next theorem, the zero and linear factors. The number c is the zero of the polynomial px if and only if the linear polynomial x minus c is a factor of p. Or we can see the relationship as the polynomial px equals the quotient times the factor x minus c. C is the zero for some quotient polynomial q. Or we say that c is a solution of the polynomial equation px equals zero. C is an x-intercept because the y is zero at that point. In different color. If p is a polynomial with a real coefficient and c is the real number. That brings to the remainder theorem. If the polynomial px is divided by x minus c, the remainder is p of c. So we can see the relationship as the polynomial px equals the quotient q times the factor x minus c plus the p of c, which is the remainder. Polynomial long division. Polynomial long division is the analog of numerical long division and provides the means for dividing any polynomial by another equal or smaller degree. I'm going to highlight it here, equals or smaller degree. The procedures for the polynomial long division. First step, we're going to arrange the terms of each polynomial in descending order. Step 2, divide the first term in the dividend by the first term in the divisor. Then gives the first term of the quotient. Step 3, multiply the entire divisor by the result, the first term of the quotient that we found, and write this beneath the dividend so that like terms light up. Step 4, subtract the product form from the dividend. Step number 5, bring down the next term of the original dividend, forming a new dividend. And step number 6, repeat the process with the new dividend. Continue until the degree of the remainder is less than the degree of the divisor. Let's take a look at the example. We're going to use the polynomial long division to write the fraction into the form of qx, which is the quotient, plus the rx, or the remainder, divided by the dx, which is the denominator of the original fraction, which also called the divisor. So this is the divisor, which is the dx. The numerator already in the descending order, power 3, power 2, power 1, and power 0. Starting with setting up the division problem, rewrite the numerator x to the third minus 3x to the second plus 4x plus 5. Long division set up with the close parentheses here, and then draw the line all across. And write the divisor x plus 2 in the front. First, we're gonna divide the leading term of the dividend by the leading term of the divisor. X to the third divided by x equals 2x to the second. So this is the result. We're gonna write the result on the top of the bar here and align with the power of the dividend. So 2x to the second. And after that, use the 2x to the second multiplied by x plus 2, which is a divisor. We will get 2x to the third plus 4x squared. And that what we bring over to the setup, 2x to the third plus 4x to the second. And then we subtract it out from the dividend. The first term will be canceled because they have the same power and the same coefficient. When you subtract, they are 0. The result is 0. And then the result from subtracting negative 3x squared by 4x squared will be negative 7x squared. And after that, you could just bring the next term down, plus 4x. Then we're going to repeat the same process. Same process, that means we are going to highlight this time. So negative 7x squared by the leading term of the divisor x. The negative 7x squared divided by x, the result is negative 7x. Or whatever we get, we could bring it to the top here, negative 7x. And how do we use it? We're gonna repeat it by using negative 7x multiplied by the divisor x plus 2. That will give us negative 7x squared minus 14x. And bring it over here. So negative 7x squared minus 14x. With 7x squared minus 14x. And repeat the same process by subtracting from the dividend from the last result. Subtract them, the negative 7x squared minus negative 7x squared will be 0. And the 4x minus negative 14x will give us 18x. 18x. So far, we have one more term to bring down, and bring down plus 5. Plus 5 here. And the next process, we will keep doing the same thing because 18x plus 5, the leading term 18x and the leading term x, they have the same degree. We will keep doing until the remainder part here have less degree than the divisor. So the next step, we just divide 18x by x. Result is 18. When we get the result, recall we're going to bring it into the long division setup. 7 plus 18 here. And then multiply 18 to x plus 2 for the divisor gives us 18x plus 36. And bring it over here. 18x plus 36 and subtract it from the dividend. 18x cancel. 5 minus 36 becomes negative 31. So far, we have the result here, negative 31, which has the power of the x0, less power or less degree than the divisor. So this is our, so this is the remainder because the power or the degree is less than the divisor. So we call the Rx or the remainder. And back to the problem here. As we see the Rx and the dx is the divisor, the result from each step is process. So this one is the quotient. Then we're gonna rewrite this fraction into the form that 2x to the third minus 3x squared plus 4x plus 5 divided by x plus 2 equals the quotient qx plus the rx, which is negative 31, divided by the dx, the divisor. We write in the alignment. Divided by the x, which is this term. Or we can rewrite it as we multiply all by x plus 2. The expression will be in the form of 2x to the third minus 3x to the second plus 4x plus 5 equals the quotient 2x to the second minus 7x plus 18 times the divisor x plus 2 minus 31.